What's up? Hello everybody, glad to see you again. In the video today, we'll then take a deep dive into the PCG Procedural Content Generation framework of the Unreal Engine. It's a really powerful tool for the Unreal Engine user to generate the content real time inside the Unreal Engine editor. So let's get right into it. To get started, let's take a look on the PCG concept. What is the idea, what is the concept behind the PCG to making it work, making it to generate the procedural content as we aiming to create today. So let's say we have the light, and then what we want to do is we want to using that light to drive and to create our content without the need of the manual crafting, manual modeling, manual modification on our mesh itself. And basically that light will then hosting, it will then populate our mesh onto it. We will then need to define where the location of the mesh will then populate, will then appear onto the light. And basically the light is made out, the light is created by the bunch of the point, maybe a million if not a billion of the point stuck together to create our lights. It's have the many of the points stuck together in there to create our light. And that point, the point is the one we want to use, the one we need to specify, the one we need to define to stack our mesh onto that point, to hosting, to populate our mesh, to able to generate the dynamic mesh, to generate the procedural content by driving just on the line. And then what we need to do next is to define what is the logic, what is the algorithm of the point, how the point will then stuck together, how the point will then connect together on the line. Because the point itself right now is not have the mesh, but on the future we then need to populate the actual 3D mesh onto that point. So we need to define what is the logic of this to drive our mesh, because we don't want the mesh to go into overlap, right? Let's try to create something with the PCG. But firstly, you will need to enable the PCG plugin. Let's open the plugin panel, searching for the PCG, and enable the PCG framework, also for the geometry scripting, external data, and then we're good to go. Okay, here are the thing that we are trying to create today with the PCG is the sidewalk combining with the lantern in the both side. And then when we drag in the point, it will then automatically create for us the nicely sidewalk. So let's do it. Firstly, we will then create the PCG wrap. Right click on the content browser, choosing the PCG and the PCG wrap. Then naming for it, in our case, we then naming is the stepping stone sidewalk, something like that. Leave it there for now. We'll then need to create the blueprint to hosting our PCG and also the spline we use to driving our PCG. Choosing the actor type, naming for it, and then open it up. We'll then need to adding some component to it for driving our PCG. Let's add in spline, the one will go into driving our PCG, and then changing the type of the starting point to the linear and leave at the endpoint to the curve. Adding the PCG component to our BP, and then in the detail panel under the wrap, we'll then need to hook our PCG wrap that we are creating in our content browser onto the detail panel. Let's compile to making sure everything is fine, and then leave it for now. Let's open our PCG wrap. Let's get spline data first, and then after that we'll then need extract the information from it by the spline sampler node. The sampler nodes will then set the base rule for the sample, the point onto the spline that we use to drive our PCG. Okay, the next is we need to define what is the rule, what is the logic to driving, to scattering our point onto the spline. And after that point will then populate our 3D mesh onto it to create our sidewalk. And then one of the critical information that we need to calculate in here is the distance. Because for the sidewalk part, it will then have the distance between each step. And then also in between each step, it will then have the gap between each step too. So we need to calculate that information. We need to calculate the distance between each step, including the distance of the gap, how big of the gap is it, and then that is the information we will then need to calculating to scattering our 3D mesh onto the spline. Let's open our blueprint and add in the variable onto it. This variable we will then using to define what is the distance between each step, and then it will using to populate into the PCG to driving our mesh scattering onto the spline. Naming it for convenience, and then changing the variable type to float. Also exposing the variable to making sure it can use with the PCG. Let compile, and then after that setting some number for the default value. In here I set something like the 100. Let's taking care for our spline sampler node. We will then change the most from the subdivision to the distance, and also ticking on the unbound. And in the detail panel, we will then see the distance increment. This is the distance that we need to taking care, and this one is the one we are setting onto the variable. Let's bring our variable into the PCG by the getActor property node, and on the detail panel we then need to changing the property name to the variable name that we create in the blueprint. Plug the getActor property node to the spline sampler node, and then we need to expose the spline sampler and find where is the distance increment. Then we plug the getActor property onto it. With this variable, we now have the control over the distance between each step, and also it's exposed inside the blueprint, so we can using it real time in the editor. Let's populate the 3D mesh onto it by static mesh spawner node, and then we can see what is the results we have so far. Press F2, renaming it for the convenience, and then after that we need to selecting what is the 3D mesh we want is to array, we want is to scattering onto the spline. On the detail panel, we then see the mesh selector, and then adding one more row for the arrays, and then choosing the mesh that we want is to scattering onto the spline. Now we have the stepping stone sidewalk with the fully dynamic. We can adjustment, we can modification is by just dragging the point and hold Alt and drag to create another point. Also, we can changing the variable that we expose inside the blueprint to making the adjustment on the distance between each step. It will then change accordingly and then automatically, fully dynamic. Okay, now we then adding the lantern onto the both side of the sidewalk. Then we are complete to create the sidewalk we aim to create today. Let's drag the static mesh spawner to the side so we can have more room to calculating the positioning of the point that we will then scattering our lantern. We will then using the same methods that we are using to calculating the distance for the stepping by creating the variable, the new variable that will specify for the lantern distance. Open the blueprint, create a new variable with the same variable type as float. Also expose and set the default value for it. Let's back to our PCG wrap, dragging out from the spline sampler, and then this time we're then using the transform point. This is will control the offset from the original point as the middle to the side. Then we can use the point on the side to populate our lantern. Copy the getActor property node. We're then using it with our new variable that we're using to control the distance for the lantern, and making sure that we are changing the property name properly with the variable name. We have the amount of the distance that we want is to offset the point to the side. to using with our lantern. But with the side, what is the direction? In here we are working in the 3D environment, so it will then have the X, Y and Z. Let's specify the direction we want to is offsetting to by using the make vector attribute node, making sure to changing the output type of the make vector attribute from the vector2 to vector, and then let's hook up the get actor property onto the Y and hook up the output of the make vector attribute to the offset min and offset max. Let's hook up the static mesh spawner to see the result. Copy the stepping stone spawn mesh and making sure to changing the mesh selector to our lantern mesh. Here we go. We are now have the lantern on the side of the sidewalk, and as you can see, it's using the same point, but it's offset to the side of the sidewalk. Changing the amount of the variable that we expose, also changing the distance of the lantern offsetting. But the lantern is just only on the one side. We actually want it on the both sides. So that is what we have to do next. Let's back to our wrap and cleaning it a little bit to make room for our another side of the lantern array. Let's copy the transform point. We'll then need it for calculation the position of the opposite side of the lantern. So let's plug the splice sampler onto the transform point so we can have the data from the splice sampler. We need the negative of the Y. This is the opposite. So we will then drag out from the make vector attribute and then we multiply it with the -1. Hook up the create attribute node onto the inb of the multiply and then changing the double value to -1. Then plug the result onto the offset min and offset max. Then finally we merging the point from the both sides into one to using it to arrange to scattering our lantern. So let's see the final result of our sidewalk with the lantern. And that's it for the video today. See you in the next one. Ciao ciao.